Hello everyone, this is the movie that I make to continue our content for chapter 3 that we finished last movie. This slide that we stopped by last movie. So this movie should be start from this slide. Okay, actually this slide I already talked or I already presented you or explained you already. Okay, we just go to next slide. Next slide is a geometric mean. Yes, in terms of major location, we have to find or we have to estimate or we have to calculate mean, median, mode. Okay, mean, median, mode. Actually, we already studied or you already watched how to find arithmetic mean, weighted mean so far. Okay. Arithmetic mean or weighted mean in terms of population data set or sample data set. But now we are going to geometric mean. Okay, so this is geometric mean. This is the definition. The geometric mean of a set of data could be population. Sorry. It could be population. If population data set, this is should be capital N, but because I use a small n, that's why this is a set of sample. Okay, geometric mean of a set of n numbers. N number, that means the data with is n number, is defined as the nth root of the product of n numbers. Okay, geometric mean of a set of data with n numbers inside or with n observation with n items inside this set can be defined as nth root of product of n numbers. Okay, the product of n numbers, what does it mean? Okay, don't confuse. The product of here is not goods, it's not services that we use for specific purpose. But in mathematics or in statistics, the product of that mean the result from multiplication. For example, I can say that the product of 2, 3 and 5. The product of 2, 3 and 5 is 30. Okay, so the product of 2, 3 and 5 is 30. How to get this one? That means that I take 2 multiplied by 3 and then multiplied by 5. Okay, I got 30. So the product of 2, 3 and 5 is 30. It could be here. In terms of mathematical expression, it should be like this one. Okay, so I can say this is the product of 2, 3 and 5. The result is 30. Okay, this is the product of. But this is n root, the product of n root. That's why there are n is 3 numbers. Okay, n is 3 numbers. Number 2, number 3, number 5. That's why n is 3 numbers or 3 amount. So if n is 3 amount, that's why this is n root, maybe third root. Okay, the third root or yes, third root for this one. Okay, this is the meaning of product of the n numbers. Geometric mean has a wide application in business and economics. How to find geometric mean? We use two applications or two cases. Case 1 or application 1. Geometric mean is useful in finding average, percentage, ratio, indexes, growth rate over time. So why do we need to use geometric mean? Because we want to find average percentage, average ratio, average indexes, average growth rate. Actually, not amount, not a quantity, not amount that we use arithmetic mean. But for geometric mean, refer to we use percentage, growth rate, ratio, or index. If you want to find average growth rate, okay, you need to use a geometric mean. If you want to find average percentage, you need to use geometric mean, not arithmetic mean. If you want to find average ratio or something, you need to use geometric mean. Or if you want to find average indexes or something, you need to use geometric mean. Okay, so the first application or the first case use, we need to use geometric mean in order to find average of percentage, average of ratio, average of indexes, average of growth rate from time to time, from period to period, that means over time. What is the formulas of geometric mean in the case 1 or application 1? It's like here. You can see x1, x2, x3 is growth rate, something like this, or is ratio, or is percentage, or is index. Okay, for example, percentage 1, percentage 2, percentage 3, percentage 4, up to percentage n. For example, growth rate period 1, growth rate period 2, growth rate period 3, growth rate period 4, up to growth rate period n. For example, index 1, index 2, index 3, index 4, up to index n. So I just mentioned inside here is a product of x1 to xn. Okay, the product of x1 to xn. This is because we have x from 1 to n, that's why the root also n root. Okay, we have n root. But if we have only 2x, x1 multiplied by x2, so we need to use only square root. Because this is square root, this is in 2. Okay, this is geometric mean. So this is a formula that we need to find geometric mean. In order to find geometric mean or something that you want to study, you need to know, for example, if x is percentage, you need to know percentage 1, percentage 2, percentage 3, percentage 4, up to percentage n of what to study. And then multiply percentage from different together and take n root. It depends on n. If you have 10 percentage, so n equal to 10. So 10 root here. Or this is ratio. It could be ratio 1, ratio 2, ratio 3, ratio 4. Or it could be index 1, index 2, index 3, index 4. X could be growth rate or something that you study, growth rate 1, growth rate 2, growth rate 3, growth rate 4, up to growth rate n, something like this. Okay, so this is application 1, that means the case 1 that you can use geometric mean. Okay, geometric mean is always less than or equal to arithmetic mean. Geometric mean cannot be or never greater than arithmetic mean. This is a disadvantage that you use geometric mean, because sometimes you want to make you want to show that okay, our achievement grow bigger. That's why if you use geometric mean, maybe you cannot have or grow bigger, because geometric mean is always less than or equal to arithmetic mean. It means that at most geometric mean can be only equal to arithmetic mean. Or the other case, geometric mean must be lower than arithmetic mean. That's why arithmetic mean can be used in order to show that how big achievement you are from growth in terms of growth rate, in terms of index, something like this. Okay. For example, suppose that your salary in this year is 350. Okay, suppose that your salary this year 350. Okay, year 1, year 2, year 3. Oh, maybe I need. Oh, sorry. This no. Okay, let's say year 1. No, what is this one? Year 2. This is year 1. Okay, so I have year 0, year 1, year 2, year 3. Now your salary is 350. Now it's year 0. Year 1, year 2, year 3. Now your salary is 350. It will be increasing your salary by 5%. Next year your salary will increase by 5%. Next 2 years your salary will increase by 10%. Next 3 years your salary will increase by 15%. Okay? So this is a graph that I just show you. So this year now your salary is 350, and it will be told you, or it will be announced that your salary will increase next year by 5%, next 2 years by 10%, next 3 years by 15%. Question: what is the average growth rate of your salary for every year? Every year that means annual growth rate. Annual that means yearly. Annual growth rate or yearly growth rate, but normally we don't say yearly, we say annual growth rate. What is average growth rate for your salary every year, or annual growth rate? What is average annual growth rate of your salary? 2. Question 2. What is the increase in your salary for next 3 years? Okay, for next 3 years. Question number 2 is linked to. Oh, cannot turn it back. Okay, cannot turn it back. It linked to 3 years. It means as in that year 0 you have 350. How about year? This is year 0. How about year 3? How much will be your salary? So, what is the increase in your salary? So, how much is your salary in year 3? Your salary in year 3 must, based on your salary in year now, plus increasing. Okay, plus increased salary. That's why question 2 asking you here. So what is the amount of your salary increasing in next 3 years from year let's say X. So your salary in year 3 must be salary now plus X. X is amount of salary increase every year during these 3 years. Okay, so based on the formula, answer for question 1 is here. So this is 5%, 10%, 15%. But why we have 1? If we don't have 1, how can you know 5%? 5% of 100%, right? Next year your salary will increase by 5%. How can you know 5%? Because this year is 100%. Your salary this year 100%. That's why next year you will get the others 5%. So actually you should have 105%, right? Next year, because this year you have 100% and next year will increase by 5%. That's why next year total will be 105. 105 if we eliminate, if we remove percentage, is 1.05. Okay. Next 3 year, 10%. 10% of what? 10% of next year's salary. Okay. 100%. This is next year's salary, not this year. That's why totally will be 1.10. 1.10. And next 3 years your salary will increase by 15%. That's why total 1.15. So you can ask, what is 1 here? What is 1 here? 1 represents your salary that you are talking now. This year, next year will be increased by 5%. Next year salary, the other next year, next 2 years, your salary increased by 10%. This is the year 2 salary. Next year, that means year 3 compared to now, increased by 15%. Okay? So you got this one. That's why we multiply them together, because there are 3 n equal to 3. 1, 2, 3. That's why we put the third root. Okay, so this is total. But this is not the growth rate. This is geometric mean. But we want to find growth rate. How to find growth rate? We talk only growth, not talking base. That's why we eliminate 1 off. Take the 1 off. Take the base off in order to find the growth rate. In order to find the change, growth rate means a growth percentage change. In order to find percentage change, take the base off. The base is 100%. That's why you multiply by 100. This is growth rate. So it means that, what does it mean? 9.92%. 9.92%. 42 something here, but I just delete some digit at the back here. Don't try to have many digits at the back. Just 2 digits. Okay. So now we have 9.92. So what does it mean? 9.92? 9.92 is average annual growth rate of your salary. Average annual growth rate of your salary. What does it mean? It means in average, year 1 your salary increased by 9.92%. Year 2 your salary increased by again 9.92%. Year 3 your salary will be increased by again 9.92 again. This is average. You can see average is same. But how about the real? The real growth rate? Next year 5%. Next 2 years 10%. Next 3 years 15%. This is actual data that we got from announcements. This is the average growth rate. Every year our salary increase the same average growth rate like this one. Okay. Number 2, next 3 years our salary will increase by 114.89, or I can say in rough talking 115. Okay, we just round it up, 115. During this 3 years, from today to next 3 years, our salary will increase totally 115. 115 not only increased by 1 year but 3 years together. That's why you want to see the first year how much increasing, the second year how much increasing, the third year how much increasing. That add all this increasing 3 years together, we will get 114.89 or 115. Because next year our salary will increase by 34.74. This is average multiplied by average. Okay. In order to make a small error, we tend to take all here. Take all here. Don't take this one. because 81 because 42 hours away. That's why this is maybe a little bit different. Next 3 years, next year our salary increased by 74%. That's why our salary next year will be this one. Our salary next year will be this one. This one come from where? Come from salary this one plus increase in salary. Okay, increase in salary. That's why next 2 years, not next year, next 2 years, we take its salary next year as a base multiplied by growth rate again. So next 2 years our salary will increase by 38.18. So next 2 years, how much is our salary? Our salary will be 442.92. But where we get it? We get it from next year's salary plus growth rate. Plus growth amount. Okay. So together here we got next 3 years our salary increase again by this amount, by the percentage. That's why we multiply by based on next 2 years, we got next 3 years. So next 3 years our salary will increase by $41.97. Okay. So within these 3 years our salary will increase by 114.89, increased by this amount within these 3 years, not only 1 year, because the first year increased by this amount, second year increased by that amount, third year increased by that amount. Together 114.89. So how much will be our salary in next 3 years? In next 3 years our salary will be increased from 350 to 464.89. Okay, this is 89. That's why again this is geometric mean of increasing growth rate salary increasing. Okay. Yes. So you can check this one. This is geometric mean in terms of case 1. Case 1, we have growth rate every year. Suppose that we have growth rate every year. Year 1 we have growth rate, we have percentage, or we have index, or we have ratio. Year 2 we have growth rate, we have percentage, we have index, we have ratio. Year 3 we have, year 4 we have, year 5 we have. That's why case 1, if you have percentage, growth rate, ratio, or index every year, you can find average growth rate by using geometric mean. Okay, like this one. Okay, to check average growth rate when our salary increase in average growth rate, not a real growth rate. This is real growth rate. This is not real. This is actual growth rate. But this is an average growth rate. So our salary increase from 350 to 464.89 or 465. Okay, our salary next year will increase by that amount. How to get this amount in terms of actual growth rate? Next year our salary increase by 5%. Okay, that's why next year our salary increase by this amount of money, 17.5, because 5% multiplied by our salary. So next year our salary will be this amount, because now our salary here plus increasing, we got this amount. And this amount next 2 years we got 10%. That's why we take next year's salary multiplied by 10%, we got increasing. This is next 2 years salary increasing. So how much will be next 2 years salary? Will be 404.25. How to get it? next year plus grow or plus amount increasing. How about next 2 year, next 3 year? Next, sorry, this is next 3 year. Next 3 year, our salary will increase by 60.64%. So if you add amount of money increase from first year plus amount of money increase from second year and amount of money increase from third year, you will get 114.89. Okay, so you can see that in terms of average or in terms of actual percentage growth rate, we have the same salary in next 3 years. Okay, this is for checking or for verification. Okay, so growth rate and actual average growth rate by using geometric mean and actual growth rate from information given, we find the same amount or the same result. Okay. Case 2 or application 2. We will use geometric mean in case 2 or application 2. Geometric mean is useful in finding average percentage increasing over n period of time. N period of time. What does it mean? Average percentage increasing. Average percentage increasing, average growth rate. See, percentage increase, that means growth rate. Okay, growth rate. Over a period of time. How many period of time? 5. If n equal to 5, yes, 5 period of times. The formula is that one. Geometric mean for application 2 come from the value at ending. For example, if you have n equal to 10 times, 10 years for example, or 10 months. That's why this is the value at month 10. This is value at month 0. Okay, month 10 and month 0. So this is ending period, this is beginning period. So in order to find geometric mean for application 2, you need to know the values of ending period, you need to know values of beginning period. In order to use application 2 geometric mean, you need to take the value of ending period divided by the values of beginning period, and when you get it, you need to take n root. How many period? If I take, let's say I say n equal to 10 years, that's why this is the 10 root. When you calculate, after you calculate 10 root, minus 1. Again, why we need to minus 1? Because we want to find growth rate. That's why minus 1 is a base. Based on your salary today, next year will be increased by 5%. That's why minus 1 is base. Minus 1 is similar to 100%. Okay. However, I take this one in order to allow you not confusing. Minus 1 is not inside the root. Minus 1 is not inside the root. Okay, outside the root. So inside the root, only value ending divided by value beginning and take a root. Okay, minus 1 is not inside. It's not inside. Okay. In terms of finance, we don't have value ending, but we have future value, the value at the ending period, and present value today. Okay, value today. So this is same thing. This is general. This is for mathematics or finance that we use a future value and present value. Okay. For application 2, we use example like this one. Suppose that Mr. Smith got salary 400 in this year. In the year 2010, and his salary increased from 400 in 2010 to 560 in 2015. Okay, Mr. Smith got salary 400 in 2010. In 2015, his salary increased to 560. So So what is average annual? Annual means per year. What is the average annual growth rate of his salary over this period of time? Over this period of time. So average annual growth rate of his salary equal to the salary ending period divided by salary beginning period. Take a fifth root. Why is it a fifth root? Because from 2010 to 2015 is 5. It means if you don't know how to get it, you just take 2015 minus 2010. That's why 2015 minus 2010 is 5. Okay, and minus 1. And note, see, minus 1 outside the root. The root is only ending by that amount. Okay, this is root. Okay, minus 1 outside the root. Don't take minus 1 inside the root. If you take, it's wrong. It's equal to, this is not a percentage. I mean, you can take percentage. Percentage will be, if you want to take percentage, it could be 6.96%. Okay, 6.96%. So every year from 2010 to 2011, Mr. Smith's salary increased by about 7%. 2011 to 12 increased by 7%. 12 to 13 increased about 7%. 13 to 14 increased about 7%. 14 to 15 increased by about 7%. I say about 7% because this is 6.96. Thus, the annual growth rate or average annual growth rate of Smith salary is about 6.96%, because we have something around here, some number around here at this area. That's why we just round it up, round it down. That's why about 6.96% or about 7%. Okay, so in this case you need to do a cell review, and again, cell review is not homework. You need to practice, but you don't need to submit. If you want me to see, okay, you can send to me. But if you don't want, okay, no need to submit. However, exercise on page 73, 74. Exercise you need to do only, yes, I write for you, because some of you still asking. Even number. What is even number? Even number, any number divided by 2, and the result is get it easily. For example, 2, 4, 6, 8, 10, 12, 14, 20, 100, 200, 2000, 1 million. Okay, 226, 306, 446. They are even numbers. Okay, so even numbers, and the deadline should be on Tuesday next Tuesday. Okay, so I write here for you because some of you still asking me about that one. Okay, this is application 1 and 2 for. Okay, this is the Excel that I make for you, that for you to have more example for geometric mean. Yes, we have case 1 and we have case 2. Okay, look at case 1. This is my money. In 2000 January 1st January 2020, I put my money into investment 12,000. Suppose that I put my money into investment 12,000, and this investment will provide me the increasing return. The first month 8%, second month 10, third 11.5, the fourth 10%, the fifth 10.5, the sixth 12%, the seventh 11%, the eighth 10%, and the ninth 9.5%. My question: what is the average monthly rate of this investment or growth? Average growth rate of this investment. This is actual growth rate that this investment provide to me, but I want to know average monthly growth rate of this investment. Okay, that means I need to find geometric mean. So based on this one, I have 9 n equal to 9. This n equal to 9. Okay, so I need to change it because this is maybe not easy. I just change it. Not percentage in term decimal number. Okay, I just change it right this here, and then I need to add 1 because based on formula I need to add base. This is your growth rate, not base. What is base? Base is my money 12,000 as 100%, equal to 100%. Okay, equal to 100%. That equal to 1. 100% equal to 1. That's why I take 1 plus this 1. Then based on formula I need to multiply this number together. Okay, it is easy. Multiply 1 multiplied by the other 1. Star here represent multiply sign, multiple sign. Just 1 by 1. And that one cannot. I type it K72. Oh, sorry, I put here the last one, K72. This one K72 because okay, K72. That's why this number. When I multiply all the number together, 1 by 1 like this one. But sometimes if you remember the product of in my slide, I read example the product of 2, 3, and 5 equal to 30. Yes. So it says it's easy. You just take product, this one product here, okay, and select all here. Yeah, same. See, this is multiplied by 1 by 1 by this. Just say product. Okay, remember that one. Next, what to do? What to do when this one? I need to put square root. Okay, square root. No, not sorry, not square root. 9th root because n equal to 9. Okay, 9 root. In Excel, we don't have. In Excel, we don't have this one 9 root like this one. But in Excel, we use. Okay, I give you example. For example, 3, the square of 3. Can I say 3 1 over 2 exponent 1 over 2? Is it equal? The square root of 3 equal to 3 exponent 1 or power 1 over 2. Yeah, the same thing. Okay, the same thing. Because this is 1, this is 2. That's 3 exponent 1 divided by 2 divided by this 1. For example, 5th root of 30. So what will we call? We call 30 1 over 5. Exponent 1 over 5. Okay? So 30, can I take 30 into what in terms of 5? Maybe no. Take 2? No, cannot be. 3 cannot be. Okay. So this is the same thing as this one. Okay, this is in terms of writing, handwriting, but Excel is not that one. Okay, Excel is not that one. Excel they use this. This is power. Okay, Excel use, for example, 3 power 1/2. You design in your, maybe your calculation for in your phone, or say you have this one. Yes, power, that's one. Okay, so don't feel strange. Okay, that's why I put this one. This is power 1/9. Okay, this is represent. This one represent 2.11. Okay, equal to that one. And then we need to take the base out. -1. Take the base out. And yet you can multiply by 100 in order to get percentage. Oh, sorry, why is no? Oh, because it's over the percentage into number. Multiply by 100%. Okay. The 10.20%. This month, it means that this month 10.27%. This month 10.27%. Average is always the same, and the same. Okay, so this is the answer. So what is the average growth rate? Okay, and so how much that I will get at the last period? How much money that I get if I invest this amount of money with the actual growth rate this one, or average growth rate this one? How much I will get it? That easy, but maybe I don't want to because okay, let's see, because some of you may take course quantitative methods, so talking about that one. Okay, just one by one for you. Maybe I put two for you. Oh, this one. Okay. This one for you. Let's say okay. This one. This is the actual one. I take the actual one. How about I take the average one? Okay, this actual one, this average one. Actual one, I put 1. Oh, I don't need to put 1. I put this one. Okay, so at the end of first month, my salary will be increased up to this one, increased by that amount, so increased by that one. How about the average one? I put color red in order to make it easy to recognize. I put you here in terms of blue, in terms of this is one red, blue that means actual, red that means average. Actual growth rate, average growth rate. So the first month will be this one. Okay. So you can see in terms of average bigger than actual. Why bigger than actual? Because my actual increase only 8%, but average up to 10%. So how about next one? Next month I will take. This is my best. Next month increase by 10%. Okay, we will increase by this one. So my salary will increase by all last period salary, last period investment multiplied by new increasing investment. Okay, this is actual. How about the original one? This is increased money. How much money I increase? I take this one multiplied by growth rate. I got increasing money. The total money come from previous one money plus increasing money. Okay, Excel is easy. I just take that one and then I take this one and then I just track here. Okay, I just track here. Why is it wrong here? Oh, because there's no here. That's why I track here. Okay. Finally, I got this amount. I put only that amount of money in the beginning investment. My investment, total investment, it returned to me 28. How about this one? Do the same way. Let's say yes, same. Yes, almost the same. Average is, by using average, I got 28,926. This is 31. This is the actual bigger than. Okay, this is in terms of using actual. This is in terms of average. Why actual bigger than? Because when I take rate is not 10.27. You see, you can take this one. Maybe how many number at the end? No, there are many number. I just cut. I just get 27. I delete 22, 21, 92, 24, 19, 31, and how many number? Too many number. Because I round up. If I take all here, for example. Okay, you take all here. To put here. If I take all here, to put there, to there. Same, see? Same. But if I cut some, only I take the 27, not all, you see? This original, there are many number beyond 27 or after 27, but I don't take. If I take only 27, so it will be smaller then. Okay, so this is the difference. But don't feel doubt or don't feel unclear or question for this one. Case 2. I put this amount of money in the first period investment, and then I know that I will get at the end of period my investment will provide me totally 23,700. I put now only 15,000, but at the end of my investment will be it will provide me 23,700,000. So again, the same question: what is average monthly growth rate of my investment? That's why in this case we know the ending and we know the beginning. Just take ending multiplied by beginning. This is not money. Okay, not money. Don't take money. This is a general. Then you take a root, right? Remember the root? Ending future value divided by present value. Take a first root. What root? Again, because 1 divided by 9. Because 9 period. Okay, and then take the 1 out. Put them as percentage. Okay, I maybe not take all. I just take 22. Okay, I will take 22. 521. 521. 521%. No, this is percentage. Percentage is what? No. 521%. the other column. Okay, if I take 520%, I will find how much money will increase for the first period. In average, my money will increase by that amount. So how much will be total in the first month? This amount. Okay, how about next month? Next month I take my first month salary multiplied by average, and then I add again average plus this is my second month. This is first month investment totally, second month totally. Okay, I'll track all here. Can see smaller than. Why is smaller than? Because I take only 521, but actually how many number is on this one? Oh, many here, up to 7 here. See, if I take all here, I put here, and I track here, it will be the same, exactly the same. Okay, exactly the same. But I don't take all, I just take 521. But beyond 21, I have this number. But I don't want to get it. But it said it's easy. But calculation, if you use handwriting to use this one, oh, so complicated. That's why you just take only 521. Only 521. So the result is different, lower. Why lower? I cut some out. Okay, cut some out. So okay, this is ending our practice for exercise, or not really exercise, for example for geometric mean. Okay, by using Excel. Excel is easy, but when you compare, when you answer by your own handwriting, that's why this is don't take all of this number, only 2 digits, 2 number at the end of decimal, at the end of 1. Here the result will be error. This is error. See, 23,700, but this is 23,690 something. Okay.